All right, students, welcome to your first worksheet in our last unit of the semester dealing with volume. Our first worksheet is going to be focusing on the video that you should have watched today, and that is how to find the volume of prisms and cylinders. Here's our essential question. What is volume, and how do I find the volume of prisms and cylinders? Now, my guidance today is going to be a little bit different than I would normally do in the class because I'm going to not write a lot of things. I'll write some things, but I'm going to be telling you what I would have written down in class, and please follow along with this. I'll give you complete guidance on this worksheet so you can be successful, and if you're not successful and can't get the answer in the answer key, send me a text and remind, and I will be happy to address your questions so you're ready for the volume test. The first part of this is just a review for you. And that is, do you understand what perimeter, area, and volume are? Now this comes right out of your flipbook notes. Perimeter, I would expect on this question for you to understand that if this is a rectangle, then opposite sides are congruent. And then over here to find the perimeter, you are add 4 plus 8 plus 4 plus 8 and find what the total perimeter is. You should be getting 24 feet. So make sure you are writing the unit of measure, 24, and then feet. What is area? So if perimeter is the distance, if you're going to walk around this rectangle, if you had this painted on the ground, it's the distance you would have to walk to get around this rectangle. Area is the space inside of the rectangle, the space inside of the rectangle. So the way we figure that out is we multiply length times width. The rule of length times width is you can't pick opposite sides. It has to be adjacent sides. So it could be 4 times 8, it could be this 4 times 8, it could be this 4 times 8. Any two adjacent sides, sides that are next to each other, you can multiply together to find the area. So we would multiply area equals length times width. So you would write down 4 times 8, and that would be equal to, in this case, area is going to be measured in squared units, or feet squared. And then we get to volume, it's basically area, but instead of just having 2 dimensions, a length and a width, it has a length and a width and a height. And we learned on the video that the way I want you to think about volume is, in almost every case, it's going to be capital B, which is the area of the base, times the height. So you're going to be taking a side or a face of this rectangular prism. Just pretend it's all by itself. It looks just like a regular flat shape. Figure out the area of that, and then just multiply it by the one dimension that you didn't use, which in this case would be 3 feet. We would call that the height. So in this case, I'm going to have 8 times 4 is going to be my base area. It's going to be 8 times 4, which is 32. And then I've got my, let's put this over here a little bit so we can move this out of the way. And then we're going to take that and plug that into here. So we'll have 32 is my area of my base times my height, which is 3. Think about the height as the one dimension that you didn't use here. I used length here, I used width here. This is the one dimension or measurement in this shape that I didn't use. That I'll call my height, and multiply that out, and there's your volume. And that's going to be in cubic feet, or feet cubed, because there are 3 dimensions here, 2 dimensions in area, and only 1 dimension in perimeter, because we're just measuring how far you walk. That's only one direction. So that becomes feet to the first power, and we don't have to write an exponent when it's just 1. Okay, clarity class, make sure you know this little 3 has nothing to do with any of these calculations here. This 2 has nothing to do with these calculations. Feet squared, and feet cubed just tells somebody that you're giving them an answer that represents distance or area or volume. That's all it does. It does not become part of your mathematical solution. All right, so there's a review right out of your flip book. For the next section class, this is again right out of your flip book, just trying to help you understand these. Here's the 3 shapes we're talking about on this worksheet. I would expect you to fill this out. For the first one, this is called a rectangular prism. The base shape is a rectangle. The base area is going to be length times width. And the volume is going to be base area times height. So you should write here, rectangular prism, rectangle. This would be, length times width, so L times W. And the volume is going to be capital B times H. And capital B stands for base area. And then on this one, triangular prism. Now remember, in the flip book I told you when you're finding the volume of a rectangular prism, you always use the rectangle as a base, no matter where, you always use the triangle as a base. So here, I could pick any face I want on a rectangular prism. I could pick the bottom, which I usually do, but it makes no difference. Any of these can be the base. Then the only dimension we use for the height is the one dimension we didn't use to figure out the area of our base. But on a triangular prism, you have to use a triangle. This is a triangular prism. The base shape is a triangle. The base area, capital B, is 1/2. It's 1/2 of length times width. Don't forget that. A lot of students will miss that on the test. And then the volume is the same as a rectangular prism. It's just capital B, or base area, times height. And the height will always be the distance between the 2 triangular faces, always. And then we get to use a little bit of stuff we learned from circles in the last unit. This is called a cylinder. The base shape is a circle. The area of that circle is pi r squared. And then the volume is just the base area times the height. And just like a triangular prism, a cylinder, the height is always the distance between the 2 circular faces. So there are your formulas for the 3 shapes for today. Next thing is a question that a lot of students will ask or struggle with which face is the base? So when we're figuring out the base for all these shapes, how do we know which one's which? Well, cylinders are easy. You can pick either of the circles can be your base. It makes no difference. I usually pick the bottom, but it can also be the top circle. Triangular prisms are also easy because it will always be the triangular face. So in this case, we've got this one, this one. I don't know how you see this shape. You may have shaded this triangle here as well. It makes no difference. And you may have shaded the back part of this shape as the triangular base. Makes no difference. When we talk about rectangular prisms, it seriously makes no difference at all. Any one of these faces can be the base. Any one of these faces can be the base. Now on this one, our issue is you can't pick, well, let me clarify that. You could have actually on this one, this oblique, you can learn this word oblique where it's kind of tilted. Any of these faces can also be the base. But on this one, class, this is not a rectangular prism. Look, we've got a 5-sided shape here. That means just like a triangular prism, you're going to have to pick this odd shape. And that's going to be your base because every other face around the outside is a rectangle. So in this case, you're going to have to pick the non-rectangular face as the base. All right, so there's how we determine a base. Let's go ahead and do one of each of these problems so you know what my expectations are. And class, hold on one second. I can't get those shapes to show up here, so let me change something. Alright, now we're good. Find the volume of each solid shown. On each diagram, shade the base and circle the height. I want you to get in that habit of actually shading the base. So when I've got a shape that's turned like this, my brain always tells me what makes the most sense is the bottom is the base. Now this won't always be the case, especially with triangular prisms. But I'll pick the bottom as my base. So my base area is length. I expect you to show me your formula. Length times width, which is 2.5 times 3. That's not written very clearly. And that value, 2.5 times 3, 2.5 times 3, excuse me while I clear my throat, 7.5. And that is area, class. That's 7.5 meters squared. My height, think about this. Here's what I want you guys to look at. Don't worry about the height being a vertical measurement. Any of these could have been the height. But since we used this number and this number as our base area, that means the other number that was never used, the other dimension, must be my height. So circle that. And then here's our height, 7 meters. How do we find volume? Volume of a rectangular prism is base area times height. Pretty simple. There's my base area. There's my height. Let's put that in our calculator. 7.5 times 7. And you've got 52.5. So 52.5 meters. Say it. You should have said cubed, meters cubed. And I'm going to circle that answer. There's my final answer. So there's the basics of how to do a rectangular prism, how to find the volume of a rectangular prism. All right. Number 2 is more practice. Number 3 is more practice. And I'll tell you, again, I don't care which of these faces you pick as the base on a rectangular prism. If you pick this side, this face right here, that means the base area would be 8 times 6. That means this becomes your height. So your third dimension is always going to be your height. All right. Oblique shapes, oblique solids where it's tilted sideways. Class, you should have noticed in your notes that for oblique shapes, this dimension, how far it is tilted, makes no difference at all. This does not help you with your volume. This measurement right here, this is the distance between the two bases, the bottom base and the top base. So there is going to be our height. Otherwise, you figure out your volume exactly the same way as you did on 1, 2, and 3. All right, here's an example. How about this triangular prism? Well, we know that the triangle has to be the base. It doesn't matter whether it's not on the bottom. Don't pick this side right here. You can't pick a rectangular face as the base of a triangular prism. So now we have our base area. We're going to use 8 centimeters and 13 centimeters. So we've got 1/2 times 8 times 13. In class, you can put this whole thing easily in your calculator all at one time. Let's do that together. If I can slide this over. And this is the way I'm going to do it. When I put a fraction in my calculator, I will always put it in parentheses so the calculator does not get it confused with my other numbers. There's 1/2, and I'll put the 8 in parentheses, and I'll put the 13 in parentheses. When there's no mathematical operator between your parentheses, your calculator knows, oh, you must want me to multiply. Press equal, and you've got 52. And that's exactly 52. Was that exact? Yep, 52. And we've got centimeters squared because that is base area. Now the height is easy. I didn't use this dimension. That's my third dimension of my shape. That means my height has to be 3.5 centimeters. And then my volume, easy peasy lemon squeezy. Base area times height. You can do that on your own. 52 times 3.5 will get you your volume of this triangular prism. All right, let's continue. We're almost done with your help. Triangular prism, easy. Pick a triangle, find the area, and then the third dimension that's not part of that triangle is your height. Don't worry about it being oblique. It makes no difference. Find the area of this triangle. The height is the distance between the two triangular bases, which is 16 yards, and you can find your volume. And then last one here as an example. Number 8, how do we find the volume of a cylinder? Well, I'm going to pick this circle as the base because it's the one that has a dimension. Doesn't make a difference. If the radius of this is 2 feet, the radius down here is 2 feet as well. Our base area is now a circle, which is pi r squared, which is pi 2 squared, which is 4 pi, and that's feet squared. So there's my area of my base. My height is the distance between the two circles, which is, I'll circle that because that's what the instructions tell me, is 14 feet. And my volume is normal, base area times height. In this case, we've got 4 pi times 14. When you put that in your calculator, you will get a decimal answer. Round that to 1 decimal place, and be sure to write feet cubed for your final volume. Okay, guidance on number 9. Please, class, don't tell me the radius is 8 millimeters. This is the diameter. Please find the radius if you know the diameter is 8 millimeters. Doesn't matter whether it's an oblique cylinder, as long as I know the distance between the two circular bases, then I can use that as my height. So that covers the 3 shapes. All right, I'm going to give you a little bit of guidance on these last 3. Number 11, solve this by factoring. Don't forget, class, you have to put all the terms on one side, so move the 32 to the other side. That's going to become negative 32. Then I would tell you, remove your GCF, which is, in this case, you can see my GCF is going to be 2 because 2 goes into 12 and 2 goes into 32. It's going to be a positive GCF because A is positive. And now that you've got your A value equal to 1, you can just use your shortcut. You can actually find your factors, write out your factored form, and then use the zero product property to figure out what are the 2 values of x that change each of these binomials to 0. What value changes that to 0? What value changes that to 0? Number 12. Solve this by completing the square, all right? Don't forget, you can't complete the square unless A is equal to 1. So remove the GCF, and then you'll get A equal to 1, and then you can complete the square. And then number 13. So, oh, by the way, class, you should notice those are the exact same equations, so you better get the exact same answers. If you don't, you made a mistake on one or both. Last one, solve this by using quadratic formula. This is your reminder. Identify A, B, and C, plug them in, and figure out what are the estimated solutions, and you can round those to 1 decimal place. And then there's your exit question. So hopefully that gets you all the guidance you need to be able to understand how to solve these. If any of these questions gives you trouble and you can't figure it out from your notes or from my guidance, send me a text in Remind saying, Mr. Z, Prisms and Cylinders, question number 8. Please help, and I'll be happy to give you personal guidance either by texting or we'll get a Zoom meeting together if necessary. Most of the time I can give you your help just by giving you some steps or some advice through texting, and hopefully that will get you through that particular question. All right, class, thank you for watching this. Hope you guys have a great Tuesday.